Okay, good afternoon, Wes. Not everyone have joined. Okay, anyways, we will start, right? We will start today's class. Okay. So I hope all of you remember what we have studied about, studied in last class. Tell me, Abhiram, you were absent in last class? Yes. Why? Tell me, why you were absent? Out of station or what? Okay, okay. Okay, so when we talk about the concepts that we studied in last class, I hope all of you remember. Okay, we studied about KTG, right? What is KTG? What are the assumptions that we take in KTG, right? Then we talk about RMS velocity. We derived how we got the RMS velocity is equal to root 3 RT by M. Then we talked about average kinetic energy of molecule. Okay, VRMS, V most probable. Then Maxwell distribution of curve. Okay, right? Maxwell distribution curve. Then we talked about what? Tell me. Degree of freedom, right? Yes, degree of freedom. Okay, then internal energy, and we studied till zeroth law of thermodynamics, right? We talked about work done, what is the basic definition of work done, what is the work done for different processes, right? So these are the concepts that we have studied in last class. Okay, so it's fine, Karishma, it's same as what you studied in chemistry. Okay, so even if you missed yesterday's class, I don't think that it should be issue with for you. Okay, you should be able to understand each and everything. Okay, right? So today we'll be focusing on first law of thermodynamics. Okay, right? Today we will be focusing on first law of thermodynamics. Now, when we talk about first law of thermodynamics, we studied that. Okay, think about it. What we have studied? Tell me. In chemistry, we studied the internal energy is the sum of. Tell me, internal energy is the sum of energy provided plus work done on the system. Yes or no? Yes or no, right? But when we talk about physics, okay, when we talk about physics, in physics, we usually talk about work done by the system. Okay, work done by the system. Okay, so the the only difference that we will have in physics and chemistry is the work done. Okay, the work done is on the system for chemistry and by the system for physics. That's why P is work done is equal to P delta V, right? Or P dV, not minus P dV, because P is internal pressure. Okay, so we have solved these kind of problems in last class itself. We have solved till question number 5th, I guess, right? We have solved till question number 5th, right, everyone? Right? We have solved till question number 5th. Okay, okay. Now, before everyone join, everyone, let's have a warm-up question. Question number 6. Okay, you can solve this using the concept of chemistry also. So no issues in this. Okay, let's try to see this. Okay, now when you talk about process A to B and C to D are isochoric, yes or no? A to B and C to D are isochoric, yes? So 0, 0, don't worry about this, right? A to B and C to D are 0. We need not to worry about this. Now when you talk about B to C, temperature is constant and volume is increased from V0 to 2V0, right? So I can say, okay, temperature is constant. So formula of work done through B to C is equal to what? nRT, right? So here T is 2T0. So it will be 2nRT0 ln V2 by V1. V2 by V1 is 2V0 by V0, which is ln2. And work done in dA is equal to, again, nRT ln. Now when you talk about V2 by V1, so V2 is V0, V1 is 2V0, so it will be 1 by 2. Got it? Tell me, got it? So I can write like this: 2 n minus nRT ln 2. Yes or no? Tell me, yes or no? So if you add them, I'll take nRT ln 2 common. So 2 minus 1 is 1. So the answer is nRT ln 2. Got it? Easy? Tell me. Easy? Yes or no? I hope all of you can solve this, right? Yes? Okay. Now, try solving question number 7. Everyone, try solving question number 7. We will be focusing, as I told you, we will be focusing more on problem solving because theory wise it is same as C6, exactly same as C6. If you have revised C6, then you must be figuring it out, right? That this is same as C6. Okay, even the questions are almost, these kind of questions are same that we have done in C6. Okay, thermodynamics and chemistry. Try to solve question number 7, everyone. Try to solve. Okay, let's try to solve this. First of all, the first thing that you have to do, both in chemistry and physics, identify the process, yes or no. So when you talk about A to B, and this is PT curve, right? This is PT. So we know that PV is equal to nRT, right, everyone? Okay. Now, if P is directly proportional to T, right? So what is this AB process? Tell me, what is this AB process? Tell me. Tell me, everyone. This AB is which process? AB and CD are isochoric process. Yes or no? Tell me. Yes or no? AB and CD are isochoric process because P by T is equal to constant. Right? Got it? Exactly. Very good, Nishita. Very good, Wes. Very good, Meet. So can I say, okay, since it is isochoric, 0, 0. Yes or no? 0, 0. Right? And BC and CDA are isobaric. So when you talk about BC, so it is what? NR delta T, right? NR delta T 1 plus, so this delta T is what? Or I'll write down this NR, this delta T is T3 minus T2 plus NR delta T, and this is NR, this delta T is T1 minus T4. Right? So this is the work done. Easy? Tell me, easy? This question was very easy. Yes? You just have to identify the process. See how easy this question was? Okay. Now, let's solve question number 8. Everyone solve question number 8. Question number 8, everyone. Okay. So let's see this. In the figure, a cyclic process is there, right? Now, when you talk about this, A to B is which process? A to B is which process? Yes, OS, right? Okay, A to B is which process? Isobaric, isochoric, right? Volume constant. Okay, so work done is 0. Okay, B to C is isobaric. So work done is P delta V. Okay, and A to C is isothermal. Now, the question is, okay, the question is, if the work done, the temperature of B and C are given, which is 500 and 1000. Okay, number of moles is 3. The work done on the gas in the process CA is this. Then find the heat absorbed or released by an ideal gas. Tell me. Now, since it's a cyclic process, we can say work done is equal to Q, yes or no, because delta U is equal to 0. Anyone have any issue in this? Anyone have any issue in this? No? Okay, very good. Right? Now, when you talk about work done is work done in BC plus work done in AC. Right, everyone? Right? Because work done in AB is 0 anyways. Okay. So I can say, okay, work done in BC is P delta V, which is NR delta T, because TB and TC is given, and work done in CA is given. Work done in CA is given, right? See, work done in CA is given. So total work done is equal to what? Work done in BC plus work done in CA. If you add them, you get 10,000 kilojoule. Now think about it. These questions, right? These questions are straightforward, easy. Yes or no? Straightforward, easy. And mostly these kind of questions will be asked in exam. Okay. Okay then, so we'll start with the next concept, which is first law of thermodynamics. Now, when we talk about first law of thermodynamics, right, it is almost same as the first law of thermodynamics that we studied in chemistry, right? Why I'm saying almost same? Because it is just different in expression wise, okay, right? When you talk about chemistry, it was delta U is equal to Q plus W, but this W was worked on the system, right? That's why we have to write it like this. But when you talk about physics, in physics, right, we usually take work done by the system, okay? So I can say the energy that we are providing is converted into internal energy plus some energy is used by the system to do work, okay? This we have already explained in last class. I hope all of you remember, right? Okay. And here the work done is P delta V. This we have studied already. I hope all of you remember. Now, when we talk about first law of thermodynamics, we have already using first law of thermodynamics. Okay, in the previous questions, right? We just didn't consider delta U. Now, what is the formula of delta U? What is the formula of U? Tell me. I hope all of you remember F by 2 nRT. Yes or no? Delta U is equal to, how many of you remember this? Tell me. Yes or no? Right? So instead of using NCV delta T, right? CV you can write in terms of F, okay, and R, right? Yes. So F by 2 R is just CV. Okay, F by 2 R is just CV, right? Yes or no? I hope all of you remember. For example, for monoatomic gas, 3 by 2 R is CV, right? For diatomic gas, 5 by 2 R is CV. Got it? Okay. Now try solving this problem. Try solving question number 9. Try solving question number 9, everyone. Right? Let's see, everyone. So in this problem, what is given? 1 gram water at 100 degrees centigrade is heated to convert into steam at 100 degrees centigrade at 1 atm. So Q you will calculate ml, yes or no? Yes or no? Right? Find out the change in internal energy of water. Okay. Now think about it. Think about it. If it is given that volume of 1 gram of water at 100 degrees centigrade is 1 cc and volume of 1 gram of steam at 100 centigrade is this cc. So I can say, okay, this Q is required for change in energy plus work done by the gas because it is expanding, yes or no? Which is P delta V, right? Everyone tell me, yes or no? Formula putting getting, yes or no? Using first law of thermodynamics. Now, you are asked to find delta U. Q is given, which is ml. Q is ml, right? I hope all of you, yeah, I hope all of you remember that. Very good, Ria. Okay. So if you see this, Q will be 540, which is ml. Straightforward, right? 540. Okay. And work done is P delta V. P delta V. Okay. Right? So obviously delta U is equal to Q minus W. So 500 calorie. Right, everyone? So those who got 500 calorie, correct. Next, try solving this. Question number 10. Everyone, try solving question number 10. Okay. Now let's think what is right. What is given? 2 mole of monoatomic gas N is equal to 2 given at 300 Kelvin. Right. So initial temperature, inside temperature is 300 Kelvin. Are kept in a non-conducting container enclosed by a piston. Now gas is compressed to increase the temperature from this to this, right? Find the work done by the gas. Now this is formula putting getting, yes or no, right? Yes or no. Now think about it. It is getting compressed. So when you talk about the formula, okay, since it is non-conducting, delta Q is 0, right? Delta Q is 0. So work done is equal to what? Change in internal energy. Yes, agree. Work done is change in internal energy. As simple as that. Right or no? Tell me. Right? So it is minus 2500 joule. Easy? Tell me. Easy? Yes or no? Yes or no? Okay. right? Okay, very good. Next question, question number 11, everyone. Question number 11. Try solving question number 11. Okay. Abhiram, are you solving? Aryan, Akshaya, Soumya, Jasharan. Okay. Ronak, Anamika, Shrihari. Everyone is solving, right? Guys, please solve, right? This chapter is easy. If you solve now, if you understood the concept now, then this chapter will be easy, okay? You don't have to worry about this chapter when you go to class 11, right? Now, in this figure, that's why I'm focusing more on problem solving. Theory I can complete in 1-2 classes. And frankly, in physics, there's not much theory which is different from chemistry. So see, a sample of an ideal gas taken through a cyclic process. This cyclic process, we know that we have already seen this process, right? Where AC is isochoric, CB is isobaric, AB is thermal. 800 joule work done by the gas during process AB. So 800 joule work is done, right? Which means nRT ln T2 by, V2 by V1 is equal to 800 given. If gas absorbs no heat in process AB, no heat in process AB, right? Rejects 100 joule of heat during BC, rejects 100 joule during BC, means Q during BC is minus 100, right? And absorbs 500 joule during AC, QAC is equal to plus 500, right? And QAB is nothing, no heat, okay, is absorbed. So total Q we can calculate. Okay, yes or no? Yes or no? Work done in AB we can know. So we can find work done in BC, right? Yes. Then after finding work in BC, we can find internal energy of the gas in BC. Agree? Tell me, agree? Right? Okay, let's solve this step by step. This is the process. Okay, so first, as I said, delta Q is equal to delta U plus W. Okay, now in AB, it is said that in AB, okay, so delta Q is equal to what? 0 and delta U plus W. Okay, so delta U is U of A and this is U of B, this is U of C. So delta U in AB is equal to what? Tell me. This, because it is 100 joule energy in BC, 100 joule of energy is rejected. Okay, got it? Wait. Forget about this. Let's solve separately. Okay, let's solve separately. Right? Forget about this. Let's solve separately. Okay, so Q total was what? Q total was what? Tell me. What is Q total? 100. This Q total was minus 100 plus 500 plus 400. Yes or no? 400. 400. Right? Work done. Work done. 800 joule work done is during process AB. Okay. So process AB work done is 800. No heat is absorbed during process AB. So I can say during process AB, Q is equal to delta U plus W. Yes or no? Yes or no? Misprint, na? That's what I said. It is misprint. Anyways, let's see, right? Forget about this. Let's see the process. Okay. So for path AB, Q is equal to delta U plus W, yes or no? Right? Let's talk about the steps now. Now it is said that no heat is absorbed in AB. Okay, so Q is 0 is equal to delta U plus W. Work done. Work done is 800. Agree? Tell me, agree? Yes, yes. It should be 1000. It should be 1000. That's why it is. That's why it is 200. Na? That should be 1000. Okay, right? That's why it is 800. Right? Yes. Anyways, this you understood. This you understood. So delta U is equal to minus 800. Okay. And when talk about this delta U from A to B, A to B, A to B. Okay, this is UA and suppose this is UB. So delta U from A to B will be what? UB minus UA. Yes. Okay. So this is delta U at this point, delta U at this point, delta U1. Okay, next at process BC, we can say that, okay, for process BC, delta U is equal to, sorry, Q is equal to delta U plus W. Same. I'm just talking about those three processes. Now Q in process BC is given as what? Minus 1000. Yes or no? Minus 1000. Minus 1000 is equal to delta U, right? Delta U plus work done. Work done is what? Tell me. Tell me, guys. W naught. Let's assume W naught. Now we know that this WA is 1000 given. WA is 1000 given, right? So this I can write like this now. UB minus WA, sorry, UA is equal to minus 800. UA is 1000. So take this to this side. So UB is equal to minus 800 plus 1000. Okay. So UB is equal to 200. Anyone have any issue? Tell me. Anyone have any issue? Yes or no? Anyone have any issue in this? UB is 200. UA is, so till now I said that this, here we have 1000 joule. Here the energy is 200 joule. Got it? Tell me, got it? Yes or no? Yes or no? Okay. Now, yes, right? Okay. So when you talk about this BC, suppose this is UC. So delta U is equal to UC minus 200. Q is equal to delta U plus W for process BC. And this is work done in BC. Okay. And Q is given what? In process BC, absorb 500 joule of energy heat. Absorb 500 joule of heat. So Q is equal to 500 is equal to delta U plus work done in BC. Right? Now for AC, we know that for AC, Q is equal to delta U AC. Yes or no? Tell me. Yes or no? Which is equal to what? UA minus UC. Okay. Now, when you talk about this Q, what is total Q? What is total Q? What is total Q in the process? What is total Q? Tell me, everyone. There's a misprint, that's why there is confusion. Okay, there's a misprint, that's why there is confusion. First of all, it rejects 1000 joule. Okay, I hope all of you got the misprint, right? Wait, sorry. That is a 1000 joule. Okay, I broke, yeah. So no, it's not 1,000. Sorry, it is 100 only. Sorry, it is 100 only. My bad. It is 100 only. It's fine. It's fine. Right? Abhiram, it's fine now because 1,000 is UA, which is given here, right? 1,000 is here. So this is not misprint. It's fine. यहाँ पे 1,000 है. Sorry, यहाँ पे 1,000 है. Yeah, sorry, यहाँ पे 1,000 है. My bad. This is 1,000. Sorry, my bad. Yeah. Yeah. Got it. Yeah. Right. So here I can say that in this case, this is 1,000. UB we calculated 200. UB we calculated 200. Updated. Yeah. Okay. Now for cyclic process, for overall process, what is delta Q for overall process? For whole process, delta Q is equal to what? Minus 100 plus 400 plus 0. Yes or no? For all three processes. Minus 500, sorry, plus 500 is equal to plus 400. This is delta Q for overall system. Agree? Now, what is delta U for overall system? Since it's cyclic process, it is 0, right? Yes or no? Yes or no? Okay. And what is work done? Work done is due to AB and BC. Work done AB plus work done by BC because AC is 0. So I can just use this delta Q is equal to delta U plus W, as simple as that, right? So delta Q is 400 plus work done by AB, sorry, is equal to work done by AB is equal to what? Given as 800 plus work done by BC. So work done by BC is minus 400, huh? Yes or no? Work done by BC is minus 400. Got it? Tell me, got it? So we got this also, we got this also. Anyone have any issues? Tell me. Anyone have any issues? Anjali? Anisha? Anikha? Soumya? Chulika? Got it? Or should I explain once again? Tell me, should I explain once again? Or understood? Okay. So see, first of all, it is a cyclic process, right? It is a cyclic process. For cyclic process, delta U is equal to 0. Yes or no? Yes or no? Right? So delta Q is equal to W, right? Now delta Q is what? Minus 100 because it is rejected plus 500. So delta Q is 400 joule. Work done is what? Work done due to AB plus work done due to BC. AB plus BC because AC is isochoric, so 0. Now work done due to AB is given as 800. It is already given. So 400 joule is equal to 800 joule plus work done due to BC. Okay, so obviously work done due to BC you can calculate. Yes or no? And internal energy we calculated by taking this UA minus QB is equal to work done because temperature is constant, right? And sorry, Q is 0. It is given that Q is 0. Okay, yes or no? Right? So from here you can find UB. Okay? Got it, Sanya? Okay, next. Right? So I hope all of you got this problem, right? Yes. Try solving this one. Try solving next problem. Question number 12. Everyone, try solving question number 12. Okay, guys, let's see. So what is the formula of internal energy? Tell me, what is the formula of internal energy? Delta U is equal to F by 2 nRT. nR delta T, yes or no? Tell me, yes or no? And I know that for diatomic molecule, F is equal to 5. So it is 5 by 2 and is also given as 2. 2 R delta T. So 2 will get cancelled. So it will be 5 R delta T. Anyone have any issue in this? Anyone have any issue in this? Tell me. All of you got this delta U? Clear? Now, using first law of thermodynamics, you can say delta U plus work done is equal to Q, right? Okay, got it? Tell me. Okay, so you asked to find what? You asked to find the rise in temperature, right? Okay, now work will be done because of what? Tell me, work will be done because of which force? Which pressure? Tell me. Work because of which pressure? Atmospheric pressure, right? Yes or no? Yes or no? Yes, very good. Very good, everyone. Okay, so I can say, okay, when you talk about work, work is what? Q minus delta U, right? Q minus delta U, Q is given as 200, delta U we calculated, and this should be equal to P delta V, right? And delta V is A delta X, area is given, displacement is given, so obviously delta V is A delta X. Pressure given, pressure is already given, yes or no? Pressure is already given. 100 kilopascal, which is about 5. Area already given, 10 centimeter cube, which is 10 to the power minus 4 meter square, right? 5 meter cube, meter square. And this delta X is also given. That's why I said Q, right? So just put it, equate it, we will get delta T is 3.6. Okay, got this? Everyone got this? Tell me, everyone got this? Shrihari, Ronak, Siddharth, Khushi, Koshi, Krishna, Mansi, Pranjal, Priyanka, Ria. Okay, very good. Samya, got it? Sneha? Okay, very good. Right? Okay. Next, question number 13. Next is question number 13. Try solving question number 13. Guys, are you solving? Please solve. Okay, let's see. An ideal gas initially at pressure P, okay, and volume V, right? Initially at pressure P, volume V, and temperature T. Okay, this is initial condition, PVT, P, V, and T. T. It is isothermally expanded to 4 times its original volume. So when it is isothermally expanded, so the work done would be what? nRT ln 4 times. So V2 by V1 is 4. Okay, right? So this is process AB. This is process AB. So work done in AB is equal to this, right? Then it is compressed at constant pressure to attain its original volume V. So it is compressed to original volume, right? Constant pressure. So constant pressure, when you talk about constant pressure, okay, so the work done in BC is equal to that pressure. Obviously that pressure would be something different. Okay, that will be using Boyle's law to find, because V1 by V2 is given, and at A, initially at A, the pressure was P, volume was V, temperature was T. Okay, so it is P delta V. P delta V. A delta V is what? 4V minus V, which is 3V. Yes or no? 3 PV, and this is P dash. P dash. It's not same as P, because this is P dash, right? Volume is 4V. Temperature is T. Okay, so it is P dash. So 3 P dash V. Yes. So P dash you can calculate now. I hope all of you can calculate P dash. P dash into 4V, P1 V1 is equal to P2 V2. PV, temperature is constant, right? Okay, so even, yeah, so even P dash will be 4V, 4P, yes or no? P dash will also be 4P. Okay, got it? Now CA is isochoric, so work done is 0. CA is isochoric, so work done is 0. Okay, got it? So draw VT curve, this is done. Calculate the total work done in the gas. Total work done you can calculate now. So this is expansion, this is contraction. Okay, so this is positive, this is negative, right? So if you put the values, you will get the answer, right? Got it? Tell me, got it? Yes or no? Yes or no? Tell me. That is what we did, right? Okay. So this is nRT ln 4. So nRT ln 4 is PV ln PV2 PV ln 2. And that was P dash into 3V. P dash into 3V. And P dash is equal to P by, right? Got it? PFVA is equal to PVVB. So PV is equal to P by 4. So 3 by 4. Anyone have any issue in this? Tell me. Anyone have any issue in this? Got it? Yes, Abhiram. Everyone got this? Raise your hand. Everyone got this? Raise your hand. Right? Very good. See, these are the type of questions that will be asked in both JEE and NEET. Okay, right? Okay, very good, everyone. Very good. If anyone is not getting anything, please ask. Okay, feel free to ask. Okay, next question is question number 14. Next question number 14. Think about it. Everyone, please check your steps. Okay, right? If not calculation, at least check your steps. So when we talk about this question, okay, a diatomic gas is heated at a constant pressure. So first thing, as I told you always, identify the process. Isobaric, okay, diatomic. So what information we will get? Pressure constant and F is equal to 5. Okay, if 105 joule of heat is given to the gas, Q is given. Find the change in the internal energy of the gas, right, and work done by the gas. Now, if Q is given and it is at constant pressure, so I can say, okay, Q is what? Q is F by 2, 5 by 2. Okay, 5 by 2. Tell me, NR delta T. Yes. Okay. Plus work done. Work done is what? Tell me, work done is what? NR delta T. Yes or no? Tell me, yes or no? And we actually know that Q for isobaric process is NCP dt. Yes or no? Yes or no? If we talk about chemistry, both are actually same, right? So actually NCPGT is given, which means this is as 105 and CP we know 7 by, tell me what is CP? 7 by 2? Yes or no? Yes? Okay. And n is equal to 1, we'll take n is equal to 1. Okay. Got it? Tell me, got it? So can I find delta T? Delta T is equal to 105 by 7 into 2. Yes or no? 15 to 30. So this is 30. Delta T is 30. Got it? Everyone got this? Everyone got this? Delta T is 30. Right? So work done is 30 R. Right? Work done will be 30 R. Yes or no? I hope all of you got this. Yes or no? Tell me. Right? So 30 joule this and 75 joule this. Got it? Tell me, got it? Everyone got this? 30 by R actually, because is R also, no? Right? When you talk about CP, we have R also, right? R by R, right? So R will be cancelled. Okay? Take your time, take your time. Don't worry, take your time. Step by step, take your time. Okay. Yeah, Q is 105 now. So we are calculating delta U first, right? Q is NCP delta T, right? It is not NCV. Yes or no, Wes? Okay. Okay. Yes. So I hope all of you got the idea. I hope all of you got the idea. Tell me yes or no. Yes or no. Tell me, guys. Right? That was enough practice for a first law of thermodynamics. Okay. Now, when you talk about chemistry and physics, okay, right? Chemistry and physics. So in physics, I personally believe the physics problem is comparatively easier because it is more intuitive, right? You can actually see, you can actually think from the piston point of view, right? How piston is moving, how work is done, and all those things, right? Okay. The next is efficiency. Okay, what is the meaning of efficiency? First of all, tell me what is the meaning of efficiency? Think about it. What is the meaning of efficiency? I hope everyone know what's the meaning of efficiency. Tell me. Output by input, yes or no? Output by input, right? That's it. That is what you have studied. Output by input. Yes. Okay. Now, when you talk about Yeah, when you talk about any engine, okay, so the efficiency of any engine, suppose you talk about your heat engine or your refrigerator or anything, you might have seen the stars, yes or no, 3 star, 4 star, like that, right? Yes or no? So we usually say that, okay, if I'm having 4 star, 5 star, then that refrigerator is more efficient, means it consumes less power and do the same work. Yes or no? Yes? Okay. So yeah, so that is called efficiency. Now, when we talk about efficiency, wait, I'll just show you. Okay. So we'll be talking about efficiency of engines. Wait, I'll just show you. Wait. Okay. Okay. So yeah, the efficiency, when you talk about efficiency, it is just output or input. We will be discussing about efficiency of engines later, but first we'll be talking about adiabatic process and polytropic process. Polytropic process. Now, I hope all of you remember what is adiabatic process. Tell me. What is adiabatic process, guys? Tell me what is adiabatic process? Anyone? What is adiabatic process? Yes, any process in which delta Q is equal to 0 is your adiabatic process, right? It is insulated. Yes, very good. Okay, and we know that if a process is adiabatic, right, then it follows a relationship which is P V to power gamma is equal to 0. Sorry, is equal to constant, not 0. Sorry, it is a constant. Constant K. Yes or no? P V to power gamma is equal to K, constant, right? Where gamma is equal to adiabatic constant, okay, which is Cp by Cv, right? This is what we have studied in chemistry. Yes or no? Tell me, yes or no? Tell me, guys, yes or no? Right? Got it? Now, when we talk about work done, think about it. When you talk about work done in this kind of process, work done in adiabatic process. Okay, so what do you think? What is the formula of work done in adiabatic process? Tell me, what is the formula of work done in adiabatic process? So we have two methods. Okay, when you talk about work done, right, I can say, okay, work done can be defined by, right, PdV, integration of PdV, yes or no? Tell me, yes or no, right? Or for adiabatic process, using this Q is equal to delta U plus W, Q is equal to 0. So W is equal to minus delta U, yes or no? Yes or no? Okay, now we know that when you talk about delta U, it is what? Minus F by 2 N R delta T. Anyone have any issue? Tell me, anyone have any issue in this? Think about it. Anyone have any issue in this? Yes or no? Yes or no? Right? Okay. Now, if we talk about it, okay, work done, I can say minus F by 2 NR T2 minus T1. T2 minus T1. So if I might take minus inside, I'll get something like this, F by 2 NR T1 minus T2. Okay, right? Now this is the basic expression for delta U, negative delta U. Okay. Now if I relate with this gamma, because obviously when you talk about adiabatic process, right, the ratio of Cp by Cv is gamma. So if we talk about this, I can say, okay, right, we know that Cv is equal to F by 2R, Cp is equal to F by 2R plus R, which is equal to F plus 2 by 2 into R. Agree? So when you talk about the ratio Cp by Cv, Cp by Cv. This is equal to what? Tell me, this is equal to what? Okay, this is equal to Cp by Cv. F by F plus 2 by F, because everything will get cancelled. Yes or no? Yes or no? And this is equal to gamma. This is equal to gamma, right? Now, if you rearrange this, what I can say, okay, we will get something like this. 1 plus 2 by F is equal to gamma, right? Yes. So from this, can I say that F is equal to what? Tell me, F is equal to what? Take one this side, then cross multiply. F will be 2 by, tell me, gamma minus 1. Anyone have any issue in this? Anyone have any issue in this? Tell me. F is equal to 2 by gamma minus 1. Clear? Is this clear to everyone? Is this clear to everyone? So can I say, okay, if I put this value here, I can say, okay, W is equal to 2 by 2 gamma minus 1 into NR T1 minus T2. 2 will get cancelled. So we will have expression, right? We will have expression of work done, which is NR T1 minus T2 by gamma minus 1. Anyone have any issue in this? Tell me. Anyone have any issue in this? Tell me. Yes or no? Yes or no? Clear? Now, this is equal to what? When we talk about NRT1, it is P1V1 minus NRT2 is P2V2 by gamma minus 1. Okay? Clear? Clear, everyone? Anyone have any doubt in this? Tell me. Anyone have any doubt in this? Yes, exactly. Because again, work done is negative what you have learned, right? Because it is work done by the system, work done by the system, work done by the gas. Okay, so let's see the expression. So this is the expression that we got. Yes or no? This is the expression that we got of work done. Right? Yes or no? Yes or no? Just focus on the final expression. Just focus on the final expression. Now, this expression that we got, right? This expression that we got is directly through internal energy. But you can actually integrate, you can actually use this relationship, right? Same as we did in thermal process, put P is equal to V to power minus gamma, integrate it, solve it, we will get this, right? We'll get this. But again, we don't have to worry about that, right? Why we need to worry about that? We are not writing the derivations, we're just writing the answer formula, which is same, which should be same. Yes or no? Tell me, yes or no? That is what we saw in chemistry also, right? Either you equate it with delta U or you derive it, it will be same. Okay, got it? Now think about it. If suppose instead of gamma, if we had X, tell me, suppose instead of gamma we had X. Here, using the derivation, if you use the derivation, if instead of gamma you would have X, which means now the relationship is this: P V to power X is equal to constant. Okay, the X can be anything. Then this is called as polytropic process. Got it? Tell me, got it? So if I ask you, okay, what would be the formula of work done? What would the formula of work done? Don't you think that would be same P1 V1 minus P2 V2 by X minus 1? Yes or no? Tell me, yes or no? Because what I did, I just replaced gamma with X. So I need not to worry about that. Okay, I need not to worry about the technicalities, or right? Because if X is equal to gamma, the work done should be same, right? So this should be the formula for work done. Yes or no? Yes, got it, everyone? Tell me, got it? Okay. Okay. Now, after this, we studied that the slope, right? When you talk about slope, x is any constant, Abhiram, x is any constant. Okay, that's just a constant. Right? Okay. Or you can just say it is a polytropic constant, right? Now, I hope all of you remember this concept, guys. I hope all of you remember this concept about the slope, that when you talk about the slope, p beta gamma is equal to constant, right? So if you talk about the slope, so dp by dv is equal to minus gamma p by v. For adiabatic, we have derived it. I hope all of you remember the derivation. Raise your hand. I hope all of you remember the derivation. Yes or no? Yes or no? Yes, very good. So I can say, okay, depending on the value of gamma, the slope will change. The slope will change. Yes, as the gamma value is more, the slope would be, tell me, more. Okay, right? Anyone have any issue in this? Anyone have any issue in slope? Tell me, anyone have any issue in slope? No, right? So generally, when you talk about expansion, okay, in expansion, isothermal, the curve isothermal will be above the curve of adiabatic. Okay, in the case of expansion, okay, in the case of expansion, the curve of isothermal will be above the curve of adiabatic, but in case of contraction, it will be opposite. Yes or no? Tell me, yes or no? Right? I hope all of you remember this. Right, everyone? Tell me, right? Okay, so this is the curve I was talking about. When you talk about, yeah, so when you talk about the curve, see, right, this is straight line is isobaric, this straight line is isobaric, this straight line is isochoric, right, this straight line is isochoric. Okay, now this curve is isothermal as compared to this adiabatic. Okay, because this is a case of expansion. During expansion, the isothermal curve is above adiabatic, while during compression, adiabatic curve will be above isothermal. Okay, right? Okay, I hope all of you remember this. Okay, so this is the general formula. This is the general formula of all the work done, Q, delta, U, and W for all the processes. Right, everyone? Tell me. So all of you got first law of thermodynamics? Tell me. All of you got first law of thermodynamics? Understood how the problem will be asked? What are the concepts? First law of thermodynamics, all the processes, right? Okay. In next class, we'll discuss some more problems. We'll try to solve some more problems based on this. And in next class, we'll be completing this topic. Okay. In next class, we'll be completing this topic, right? Only a small portion of topic is left. Okay. Very small portion of topic is left. So we'll be solving some more problems. Okay. We'll be solving some more problems. And then, yes, and then we will talk about the efficiency. Okay. Now, so this is what I was talking about. This is what I was talking about. Okay, so if p beta gamma is equal to constant, this is something that we'll talk in the next class. Don't worry, we'll talk about this polytropic process and everything in detail in next class. Okay, right? Okay. I've taken the screenshot. Many students. Okay, anyways, okay, bye everyone. Take care. Bye everyone. Please go through all the problems of the sheet that I've sent. Okay, right? I'll upload another sheet. I'll upload this material also. Okay, please go through the example of this material. I'll upload this. Okay, right? There are lots of solved examples. First, try to solve as many as solved examples as possible. Okay,